Hey everyone, and welcome to lesson 3.10. Today we are going to focus on difference of squares. So if you remember from a few lessons back when we were expanding, one of the special products that we had where when you had two brackets where the numbers and the variables inside were the same but the signs were different. And if we were to distribute this out, we'd actually just end up with two terms, an x squared and a minus 9. The x squared and the 9 are both perfect square terms, so basically you can take the square root of each one of them, and they're separated by a minus sign. So we call this a difference of squares. Even when you're looking at this next example, you end up with 16x squared minus 81. 16 and x squared are perfect squares, as is the 81. So let's kind of come up with a way to factor this. So on the last page, we said that x plus 3x minus 3 was equal to x squared minus 9. Now, if you look at the first term of x squared, and if you took the square root of that, notice that we will get x, which happens to be on the left side of each one of these brackets. If you took the 9 and you took the square root of that, which happens to be 3, that happens to be on the right side of each one of these brackets. So when you're going to factor, you take the square root of the first term, you take the square root of the last term, and then you give one of the brackets a plus sign and you give one of the brackets a minus sign. And that's how we basically factor difference of squares. That's kind of the shortcut. Another method when you have these two terms is to kind of treat it like a trinomial. X squared minus 9 would be the same thing as saying x squared plus 0x and then minus 9. If we treated this as a simple trinomial, we're looking for two numbers that multiply to negative 9 and then add to 0. So those two numbers would be a plus 3 and a minus 3. And that's why we can put the plus 3 in this bracket and we could put the minus 3 in the next bracket. Okay, so either way, whichever way you like to think about it, that's how you can factor a difference of squares. I'm just going to backtrack for 1 second, and I want you to make a note that a sum of squares will not factor. So for example, a sum of squares would be, let's say, x squared plus 9. That is not factorable. Okay, only difference of squares are factorable. Okay, so let's move on with our lesson and try a few examples. So however you want to treat these difference of squares, whether you want to take the square root of each term and give one bracket a plus and one bracket a minus, or whether you want to treat it like a trinomial where that middle term is 0, totally up to you. I'm going to use the difference of squares method where we square root each term. So I'm going to open up two brackets. On the left side, I'm going to look at my first term and take the square root of x squared. On the right side of each bracket, I'm going to look at 49 and take the square root of that. One bracket gets a plus, one gets a minus. Okay, so let's kind of go through the motions. I know that I need to check for common factors first, which there aren't any. I know that there's two terms, so we're going to treat this like a difference of squares. 25, x squared, 64, and y squared are all squares, perfect squares. They're separated by a minus sign, so because it checks out to be a difference of squares, I can take the square root of the first term, the square root of the last term, and then one bracket gets a plus and one gets a minus, and that's it. Okay, in part C, remember to always common factor first. So looking at this right now, 2 is not a perfect square, and neither is 72, but 2 is common to both terms. So we'll take that out, we'll factor it out, and we are left with x squared minus 36. Inside the bracket, what remains is a perfect square, another perfect square, and they're both separated by a minus sign. So that means I can open up two sets of brackets, take the square root of the first, the square root of the last, one gets a plus and one gets a minus. Taking a look at question D, basically any variable that has an even exponent can be square rooted. So x to the power of 4, you're looking for two things that are the same that multiply to the x to the power of 4. So x squared times x squared would give us our result. So x to the power of 4, if we were to square root it, would just be x squared. X to the power of 6 square rooted would be x cubed, because x cubed times x cubed, add the exponents, gives us x to the power of 6. Okay, in any case, so I cannot common factor, and I see I have two terms, all that are perfect squares. They are separated by a minus sign. So I am going to open up two brackets, square root the first term, square root the last term. One gets a plus and one gets a minus. Now take a minute and look at your answer. Are you fully factored? Well, if you look at the first bracket, this has two terms. I cannot common factor, but it has two terms. Both are perfect squares, but this time it's separated by a plus sign. This is a sum of squares. We know, as we said earlier, it is not factorable. But if you look at the second bracket, we have two perfect squares, the 4x squared and the 9, this time separated by a minus sign. Now we have a difference of squares. We are not fully factored because I have another difference of squares here. This 4x squared plus 9, we can't touch, it's not factorable, but the 4x squared minus 9 is. So I'll open up two brackets, square root the first, square root the second. One bracket gets a plus and one gets a minus. Okay, and the last example on this page, although there are fractions, each numerator and denominator is a perfect square, separated by a minus sign. So, nothing to common factor out. So we will open up two sets of brackets. Now we'll square root the first term. To square root a fraction, you square root the numerator and the denominator. Okay, square root the second term, numerator and denominator. One gets a plus and the other gets a minus. Okay, so that's the basic idea for difference of squares. So in the next few questions, you'll see a few binomials that are being squared. Sometimes it's helpful to use substitution. You can substitute that with a variable. I will show you both ways where you do use substitution or if you choose not to. And then it'll be up to you on how you tackle these questions. So in this question here, we have x plus 3 all squared minus 4y squared. So we go through the motions. I cannot common factor. I count the terms, and I see that there are two terms, something squared minus something else squared. Everything is a perfect square, so we're going to treat this like a difference of squares. So I'll show you kind of the direct method. We are going to open up two sets of brackets. Now the square root of a binomial squared, so we have x plus 3 all squared, and we want to square root it. Know that kind of the square root and the squared kind of cancel each other out, so what we're left with is just the x plus 3. So that goes on the left side of both brackets. The 4y squared, we'll take the square root of that. One bracket gets a plus, and one gets a minus. Now if you can, collect any like terms. However, there's nothing like to be collected, so we can leave that as is. If you wanted to, you can arrange it so that you have the x, and then the y, and then the plus 3. Okay, so sometimes using substitution can be helpful. So what we can do is let some variable that's not x or y, so let's say w. Let's say we had w was equal to our binomial. So we can rewrite the question as w squared minus 4y squared. It's a little easier on the eyes and it's easier to kind of deal with. So we treat this like a difference of squares. We'll open up two sets of brackets, square root the w squared, square root the 4y squared. One bracket gets a plus and one bracket gets a minus. Just remember that w is never part of your question, and so you have to sub back in for w. Okay, so wherever you see a w, you're actually going to write the original x plus 3. And in both cases, you get the same answer. So whichever method you're more comfortable with is the one that you should go with. Okay, let's try one more. So again, I will show you a direct way and the substitution way, and then you can choose. So I have two terms, both squared, being separated by a minus sign, so I'm going to do difference of squares. In this case, it's super important to stay organized, so you are going to use brackets inside of square brackets. So the square root of this first term is just going to be what's inside the brackets, the 7x plus 2. And the square root of the last term is going to be 4x minus 3. Again, using brackets. And the reason that the brackets are so important is because one bracket gets a plus sign and one bracket gets a minus sign. Remember that when you are subtracting a binomial, you must distribute this negative. And that's why the brackets are so important, because you don't want to write just minus 4x. You need to change the sign on the 3 as well. So in the first set of square brackets here, to get rid of these inner round parentheses, you're just distributing a 1, so really nothing changes. We have a 7x plus 2 and a 4x minus 3. But in the second set of square brackets, we have the 7x plus 2 and then minus 4x and a plus 3. Super important. Now we can collect like terms. So the x's collect to give us 11x, and the constants collect to give us negative 1. And finally, 7x minus 4x, and the 2 plus 3. So that is fully factored there. Okay, if you are comfortable with this, that would be the end of the lesson for you. Again, if you have any questions, make sure you ask in class. I will show you the exact same question now using the substitution method. So we're going to come up with two variables. So let A equal 7x plus 2, and let B equal 4x minus 3. So we can use that to rewrite our equation as a squared minus b squared. And if this was our question, well, it's a difference of squares. So open up two brackets, square root the first term, square root the second term. One gets a plus and one gets a minus. But same as last question, a's and b's were never part of your equation, so you need to substitute. A was really 7x plus 2. B was the 4x minus 3. And don't forget your brackets. So essentially we're at the same step as we were using the direct method, where you want to collect like terms, but first by getting rid of the inner brackets. So 7x plus 2 plus 4x minus 3, and then 7x plus 2 minus 4x, and then plus 3. Collect like terms, and you should end up with the exact same answer as before. Okay, so this ends today's lesson on difference of squares. If you have any questions, make sure you ask in class, and I will see you next time. Take care, guys.